This video is for the probability and statistics lesson, sample spaces, events, and outcomes. Of course, within this lesson, there are two learning objectives, as you can see. They're both very related to each other. Our two objectives are to determine the sample space for a given event or series of events, and to produce an organized list of outcomes within the sample space. Ultimately, those are saying, if something happens, can you provide a list of all the different possibilities for what could actually happen? We have 4 vocabulary words within this lesson: sample space, outcomes, event, and tree diagram, though we will not discuss them in that particular order. The first one that we will look at is an event. Quite informally, an event an event is something that can happen in different ways. A good example are, you flip a coin. Coin could happen to fall on heads, it could happen to fall on tails. If you're shooting a basketball, you could hit, or you could make it, you could miss it. An outcome is one specific result from an event. Using the example I just noted, shooting a basketball, one outcome is you make it, one outcome is you miss it. A sample space is a list of all possible outcomes. All the possible results of an event. And a tree diagram is a tool that can be used to find the sample space, particularly if you're having a series of events instead of just a single event. A good example, of course, is if you shoot the basketball, well, you shot it once. You could either make it or miss it. But what if you shot it 5 times or 10 times? What are all the possible ways that event could unfold? A tree diagram would help you track the possibilities. I encourage you to pause the video, write down the notes. You may not have had enough time to keep up, so at any time, if you need to pause the video, by all means, do so. Here's our first of 7 examples. Terrence will flip 2 coins. You can build a 2x2 grid to show what might happen. Okay, so with our 2x2 grid, starting off, coin 1 has 2 possibilities. You could get heads, or you could get tails. If we look at coin 2, we likewise have 2 possibilities, heads or tails. By mapping out all of a 2x2 grid, we can start filling them in. Looking at each square, top left, heads on the first, heads on the second. Heads on the first, tails on the second, tails on the first, heads on the second, or tails first, tails second. So there we built our 2x2 grid quite quickly. To answer the 2 questions that we were asked, the event is the thing that could happen in 2 different ways. Quickly enough, the event would be Terrence flips 2 coins. it has different possible results, different outcomes. Our sample space we can take directly from the grid. We had heads, 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 tails, tails, heads, and tails, tails. 4 possible outcomes in our sample space. Also need to have you use a specific notation. Mathematicians have decided sample spaces are sets, and sets always use these curly brackets for them. Whenever you talk about a sample space, you will use those. Example 2 is similar, a little bit more difficult. I encourage you to pause the video, try to answer these 3 questions first. After trying them on your own, unpause the video and you can see my solution. Starting off from here, what is the event? Peyton rolls 2 standard dice. Build a 6x6 grid to show the different outcomes that might happen. Well, our event is the thing that is being done. He's rolling 2 of these standard dice. Now, to list all the possible outcomes, we know that he could get a 1 and a 6. He could get a 2 and a 6, a 3 and a 6. Trying to list them all for some people is a little bit difficult. That is why we will take advantage of a grid. We can say on the first dice, the first die, we have the 6 standard possibilities. On the second dice, the second die, we still have the same 6. So we have dice number 1 and dice number 2. We could build a very large 6x6 grid that will allow us to track all of these. So let me start filling in the lines. Each one gets its own column. Each one gets its own row. Okay, there we go. Now, I'm going to change the color to red so that way I can delete this. You'll note you'd have 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6, and I could keep going to fill in the rest of them. However, that's not going to actually help us with what the questions were asking. The questions asked not what is the sample space for all the possible rolls. Instead, we were asked what is the sample space for the different sums you might get. That's the important part, the different sums. They were not asking for 1 and 1, 1 and 2, 1 and 3. They wanted us to add the numbers up. So backing, didn't mean to do that. Backing up and removing those in the red, we could go through and add them together. 1 and 1 make 2. 1 plus 2, 1 plus 3, 1 plus 4, 1 plus 5, 1 plus 6, 2 plus 1, 2 plus 2, 2 plus 3, 2 plus 4, 2 plus 5, 2 plus 6, 3 plus 1, 3 plus 2, 3 plus 3, 3 plus 4, 3 plus 5, 3 plus 6. And I'm sure you could start spotting some of the patterns already. We could start filling them in. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, 12. And this grid then lists every single possible outcome, every single possible sum. Now we'll note some of them are more likely to happen than others. For example, the 2, there's only one way that you're going to get the 2. You have to get 1 and 1. Likewise, the only ways that you could get an 11 are to have 5 and 6, or backwards, 6 and 5. that actually plays a role in the question that was being asked here. What is the sample space? Okay, so our sample space, writing in complete sentences, because even in a math class you always write in complete sentences. The sample space is, and we'll use our set notation, and we just have to fill in everything that we had. Well, 2 is the smallest, 12 is the biggest, so we'll just fill them in. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All of those are possible outcomes in our sample space. Coming back to what I noted, part C asks which outcome occurs the most often. Well, we can just look at the grid and see which number is there the most. We can see it's 7, so the most frequent outcome is 7. We're done. That finishes off this example, answering each of the 3 things that we were asked to do. So we'll go to example 3. At Denny's in Minot, you can build your own breakfast meal. The child's menu lets you choose between milk or juice. You can also choose between ham, sausage, or bacon, and you can choose between eggs or pancakes. Part A. Give the sample space that shows all the different outcomes for what the child might order. Okay, so part A. We have to go through and make... well, first off, there are many different ways that we can do this one, showing you just one particular method. And I'll start by writing out my complete sentence. Okay, a sample space is... All right, so we'll start with our first choice. We can have milk or juice. Well, until I figure out every single possibility, I'm just going to start by saying, I have milk. Well, after you choose milk, we then have to make another decision. Ham, sausage, or bacon? Well, I'm going to pick ham. So I have milk, then ham. For my last one, eggs or pancakes. Well, I could pick eggs for the first one, giving me the meal, milk, ham, eggs. And very close to it, milk, ham, pancakes. Well, that takes care of milk and ham, so with ham being gone, I could then move on to my second option, milk, then sausage. So milk, sausage, and eggs, or milk, sausage, pancakes. Sausage is gone, so I have to go to my third option. Milk, bacon, eggs, milk, bacon, pancakes. And now bacon's done. You notice how all 3 options are exhausted? Well, that tells me that those pieces are done, so now I can back this up and say milk is done. I've already finished it off. Well, instead of having milk now, I can have the different meals with juice. Basically, they're the same thing. Juice instead of milk can still be paired with ham and eggs. Juice can be paired with ham and pancakes, sausage eggs, sausage pancakes, bacon eggs, and bacon pancakes. So, there we go. Oh man, my line is slanting. I didn't mean for that to happen. And we gotta have set notation. There we go. We have our sample space. Part B is pretty quick, well, rather perhaps easy. How many different outcomes are possible? We have the entire sample space. We can just count them. Count up how many are there. We have 12 possible meals. our next example is pretty much the same. We've just expanded the menu. Children can now choose milk, juice, or water, still have the choices of ham, sausage, bacon, but now they get eggs, toast, pancakes, French toast. We can still go through using any method we'd like to show all the different outcomes. So let's start off doing the same thing. The sample space is, and we'll start with milk. Well, we can have milk and ham. After picking milk and ham, we could have eggs, milk, ham, toast, milk, ham, pancakes, milk, ham, French toast, using the F for French. Okay, with ham exhausted, we can then say we can have milk, then sausage and eggs, milk, sausage, toast, milk, sausage, pancakes, milk, sausage, French toast. And now sausage is done. So we'll go on to bacon. Milk, bacon, eggs, milk, bacon, toast, milk, bacon, pancakes, milk, bacon, French toast. And I'm running out of room. I'll have to write a bit smaller on my next line to give me more room. Okay, so that list completely takes care of milk. With milk done, we pretty much already have the menu set up. We just have to change it. Instead of having milk, now we can have juice. So juice, ham, eggs, juice, ham, toast, juice, ham, pancakes, juice, ham, French toast, juice, sausage, eggs, juice, sausage, toast, juice, sausage, pancakes, juice, sausage, French toast, juice, bacon, eggs. Oh, my E didn't come out quite right there. Juice, bacon, toast, juice, bacon, pancakes, juice, bacon, French toast. And then juice is done, which will allow us to move on to water. So same thing. Water, ham, eggs, water, ham, toast, water, ham, pancakes, water, ham, French toast, water, sausage, eggs, water, sausage, toast, water, sausage, pancakes, water, sausage, French toast, water, bacon, eggs, water, bacon, toast, water, bacon, pancakes, water, bacon, French toast. So there we go. We have our entire sample space. Pretty large, and I'm not sure how well my curly brackets are going to pop up. I ran out of room there. So yeah, pretty big. How many total outcomes were possible? Well, we can say just for milk, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 options for milk, 12 options for juice, 12 options for water. 12 plus 12 plus 12 gives us 36. So yeah, quite a bit. But we've been able to complete this example noting our two options. Now I ran through this particular method because it's something that kind of works for my brain. You know, this is kind of the way I think. A lot of people find this particular method of tracking to be a little bit more difficult. There is another method that we had discussed before with our vocabulary of the tree diagram. A lot of people prefer to use the tree diagram because they find it easier to work with. Either way, whichever technique we choose, what we're trying to do is to determine our sample space. Whether you choose to use a tree diagram or you choose to just try to mentally work your way through to create that list of outcomes, it doesn't really matter. You just have to be able to track it and make sure that you don't lose any possibilities. Showing you with this example that we just finished, we will try to find those 36 different options by using a tree diagram. Basically, the idea behind the tree diagram is you would start off and say, I have a choice to make. So I'm using this dot to say choice number 1. Well, there are 3 possibilities for choice number 1. You could choose to have milk, you could choose to have juice, or you could choose to have water. Then you have another choice to make. So I'll use another dot at each juncture where I can make a choice. If I pick milk, that will then let me pick the second choice of, I don't remember the order, it was ham, sausage, bacon. So I could pick ham, I could pick sausage, or I could pick bacon. Likewise, ham, sausage, bacon, ham, sausage, bacon. Well, after each one of those, I still can make another choice. So I'm putting down a dot for each one of these. From here, I can then choose, do I want, our options were eggs, toast, pancakes, French toast. So do I want eggs? Do I want toast, pancakes, or French toast? Eggs, toast, pancakes, French toast. 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 And of course you can see how repetitive this is because you still have the same options over and over and over. Eggs, toast, pancakes, French toast. Eggs, pancakes, toast. I actually put those in backward order. Eggs, toast, pancakes, French toast. When I said backward order, I meant here. I'd been going eggs, toast, pancakes. Eggs, toast, pancakes. I had those 2 flipped around. My brain just flipped them for a second. Okay, here's our tree diagram. It looks really messy. A lot of people prefer, instead of going from left to right, they would instead prefer to say, go down. And then they could have branched it off like this. 1, 2, 3, 4, 1, 2, 3, 4. You still wind up with this part where you see how we're starting to get really crowded. It's just tougher to work with. So if you're going to, however you're going to do this, if you know you have a lot, you need to really, really space these out. If I were working on a sheet of paper, I would have gone more than this, but I was limited by my board with how much space I had to show. So I tried to cram it in a little bit. It didn't work particularly perfectly. I'm not really happy with it, but you got to work with sometimes what you got. Now, this is just the tree diagram. This does not give us the full list that we had before. Well, we can trace each path. Milk, ham, eggs. That's one option. And then we can take milk, ham, toast. Milk, ham, pancakes. Milk, ham, French toast. Where some people really like this is they can follow each individual path and they make sure that they get all possible values. Creating the sample space like I'd done before can be pretty difficult sometimes you have to be really careful that you don't accidentally skip something, you don't accidentally miss something, because it is kind of tricky sometimes. The tree diagram, make sure you get them all, but as you noted, it's a lot of work. Now, to help show the rest of these, I'm going to change my colors. I can then still have milk, and then sausage, and eggs. So milk, sausage, eggs, milk, sausage, toast, milk, sausage, pancakes. And you notice the pattern, how I have milk, sausage, milk, sausage, milk, sausage, milk, sausage, French toast. Well, basically, I'm making my first two choices, just saying milk, sausage. Well, I could do the same thing here. Milk, bacon. So all of them are going to be built on having milk and bacon. Since I know I've got those four choices, I could just fill them in then. Eggs, toast, pancakes, French toast. And now you'll look at my colors, how I have yellow, red, and blue. They completely filled up this first choice. That's where I was saying before, now milk is done. I was able to get rid of all the different options by listing them out, just following the branches on the tree diagram. Well, of course, I'll have to do the same thing here, and I'll switch back to a green color on this one. So I'd have juice, then ham. So juice, ham, juice and ham, juice and ham, juice and ham, which will allow me to track through the last four options. Juice, ham, eggs, juice, ham, toast, juice, ham, pancakes, juice, ham, French toast. Eggs, toast, pancake, French toast. Same thing then with ham being done. I'll switch to purple for this one. I could have juice, then sausage. So juice and sausage with my four different possibilities. Eggs, toast, pancakes, French toast. Filling in those four branches. And this time I'm going to go to black because I haven't used that yet. So juice and bacon. Juice, bacon, option 1. Option 2. Option 3. And option 4. It's not a very attractive F. Which finishes off our four different options that we had there. Bringing us, of course, to the water, and I got to switch back to colors that I've already used, so I'll go with the red here and say same options. We had water, water, and you'll note how these are filling in just the same as what we had before. So water, sausage, eggs. Oh, wanted to change the color there. Oh no, went too big of an eraser. Smaller eraser. And I'll switch the color to, I don't know, blue. Oh, too much. Oh, okay. Water, ham, pancakes, water, ham, French toast. Now I'll go to blue. Water, sausage, eggs. Water, sausage, toast. Water, sausage, pancakes. Water, sausage, French toast. And I'll go to green. Water, bacon, eggs. Water, bacon, toast. Water, bacon, pancakes. Water, bacon, French toast. So yeah, it's a lot of work. Why would we want to spend this much work on them then? Well, one of the big reasons why tree diagrams are so incredibly helpful are not with problems like these where it's very, very easy to say, well, we always have these same options of milk, juice, water. We always have the option of ham, sausage, bacon. We always have the options eggs, toast, pancakes, French toast. What if we pick ham and then ham can't go with pancakes? What if we pick milk and then milk is not allowed to go with sausage? When you start adding in other criteria that is a bit weird, this becomes a more beneficial tool. our example number 7 will actually illustrate that. Pretty tough example. Tree number 6, much simpler version of the tree diagram. You should actually pause the video, try finishing problem 6 on your own. Dart player is aiming at the bullseye. She has 3 darts to throw, and with each throw she can hit or miss. Only 2 possibilities. Build a tree diagram to track what might happen. Well, I'm going to choose to use a vertical tree diagram. So for option number 1, 2 things can happen. A hit or a miss. Then she's going to throw the second dart. 2 different things can happen. Hit or miss. Then she has to throw a third dart. And once again, 2 things can happen. Either a hit or a miss. This problem is finished. We were asked to build a tree diagram to track what might happen. We did that. We could, of course, take this further and actually list the entire sample space just by tracking the branches. Hit, hit, hit. That's one possibility. We could also have hit, hit. I didn't write an M up there. I don't know why I didn't write the M. I apologize for that. We could have hit, hit, miss. Then we could have hit, miss, hit. Hit, miss, miss. Tracking down, we could have miss, hit, hit. We could have miss, hit, miss. Miss, hit, miss. Then we could go miss, miss, hit. Oh, didn't draw it. Miss, miss, hit. And then the last option, miss, miss, miss. And so we could track it and get our answer. This problem number 7, this example, is kind of tough. If you don't want to try this challenging problem, you could end the video now. This is more for people who want to go for advanced and see if they can pull their way through it. Softball pitcher wants to get a strikeout. Okay, with each pitch that she throws, she can get a ball, a strike, or they can hit it in play. Now, sports, of course, aren't instantly predictable. If you get 4 balls, the at-bat is over. If you get 3 strikes, it's instantly over and there's no other options. And if they hit it in play at any point, it's instantly over. We are going to try to build a sample space using a tree diagram of what might happen. This is going to take a lot of space, so make sure you're giving yourself pretty much one whole page to work through it. So, option number 1. She throws the first pitch. One of 3 things can happen. There could be a ball, a strike, or hit in play. Pitch number 2 allows, and to help make this easier, I want to separate this into 3 columns so I don't get it quite so crowded and quite so disorganized. So I'm putting these columns down just to try to keep it more organized. But I should actually change these, because if there was a hit right here, this at-bat is over. We can't go through and say, oh, what's going to happen then? Once it's hit in play, it's done. There's nothing else. So we can actually say at this point, there's no more. We don't need to create that extra space there, because that is done. There's nothing else that branches off of that. So based on a ball or a strike, we could then branch off. Three things can happen. We could have a ball, a strike, or a hit. Once again, the hit would end the at-bat. So we only need to consider what would happen if we branched off the other two. Well, we could have a ball, a strike, or hit and play. Same thing. We could have a ball, a strike, or hit and play. Hit and play ends them, so that's why I'm highlighting them to remind me that I don't need to do anything else. Now I'm going to switch colors here to yellow so that we can continue tracking this one. Here we had ball 1, ball 2, ball 3. At this point, we still have the three options: a ball, a strike, or a hit. In this instance, this is ball number 4. That would end the at-bat. Hit and play would also end the at-bat. Okay, but we'll need to branch down over here and say we could have a ball, a strike, or a hit. We know the hit would end the at-bat. But this ball does not end the at-bat though, because, and I'll do this one in green, we had ball 1, ball 2, strike 1, ball 3. This ball is not ending the at-bat. We would have to continue going further. On this one, we could then say ball, hit, strike, ball, strike, or hit, ball, strike, or hit, and we'll have to map through both of those. We had, at this point, remember, we were at ball, ball, strike, so 2 balls, 1 strike, 3 balls, 1 strike. This would be ball 4, which ends it. That would be strike 2. So at this point, we have the count: 3 balls, 2 strikes. This one was the count: 1 ball, no strikes. And I'm thinking now that putting this in would have helped keep track of it. So 2 balls, no strikes, 1 ball, 1 strike, 3 balls, no strikes, 2 balls, 1 strike. This one is 2 balls, 1 strike. Wait, I have to back that one up because I made an error. This is, at this point, ball, strike. Yep, so 2 balls, 1 strike, 2 ball, 1 ball, 2 strikes. And filling these pieces in, this is 4, 3 and 1. This is 3 and 1, 2 and 2. This would be 2 and 3. 3 strikes ends it, so that would end the at-bat. But this one is 3 and 3. The hit would end the at-bat. And then this one we would have to go and say, from here, ball, strike, hit, ball, strike, hit. This would become, oh, I'm sorry, this was 4 and 2. This would be 4 and 2. This would be 3 and 3 for the hit. In either way, 4 balls would end it. 3 strikes would end it. The hit would end it. Okay, and so here we're starting off the 3-2. This one was the 4-1 walk. Now at this point we have coming down the ball, the strike, or the hit. The ball would make it 4 and 2. The strike would make it 3 and 3. And the hit, of course, instantly ends it. So we've got guaranteed right there. Ends it, ends it, ends it. Okay, we still have another one. Over here where we had the 3-1, ball, strike, hit. The ball would make it 4 and 1. Ball 4 would end it. The hit would end it. But then we'd have to go over and say ball, strike, hit. Coming off the 3-2, that would be 4-2. This would be 4 or 3-3. Each one of those, oh, I need to switch to red. Each one of those would hit it. And that ends those branches. We still got to come up here, and we have the 2-1 and the 1-2. So really messy. Ball, strike, hit. Ball, strike, hit. Okay, hit ends it. This one would have been 3 strikes. So that would have ended it. But that would be 2 and 2. So that tells us that it could branch off. Ball, strike, hit. Just like before, the hit ends it. That would be strike 3 with the 2-3 count. But then this becomes 3-2 with the ball. Still does not end it, so we'd have ball, strike, hit. Hit ends it, strike ends it with the 3 and 3, or the ball and that one ends it with 4 and 3, or 4 and 2. So there we go. We have this huge, really complicated tree diagram. And all of those were based only on the idea that you get a ball on the first pitch. If we count each of the red letters, that will tell us the number of different possibilities we would actually have. So let me go through and try to count them out. And to help out with that, I'm going to switch the color to this kind of orange color. And so we have, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. I think I got them all. Yep. There we go. That option, there are 29 different ways for an at-bat to end in softball if it starts with ball 1. If it starts with a hit, hooray, there's only 1. So already we're up to 30, and we have not even done the strikeouts, the first pitch strike. Again, I said this would be a tough problem. This is definitely an advanced problem. This is way above what the standards would actually want you to do. But if you can do this, and if this is making sense, then that's a very, very good sign for you. So we're starting off this pitch, strike 1. And we have the options, ball, and I'm going to swing this way over more. Strike or hit. Well, of course, we know the hit ends it, so that's good. Putting in the counts, this would be 0 and 2. This would be 1 and 1. I'm going to work over here with the strikes first. Ball, strike, hit. Hit ends it. The strike would be 0-3. The ball is 1-2. So strike 3 ends the at-bat. we'd have ball, strike, hit. We know the hit ends it. The strike would end it with a 1 and 3 count. And then the ball makes it 2-2. Okay, so we'll branch off here. Ball, strike, hit. Hit ends it. This would be a 2-3 count, which would end it. And then this would be a 3-3 count, which keeps it going. So then this can branch off. Ball, strike, hit, which gives us a 4-2 count or a 3-3 count, or the hit automatically ends it. Either way, that ends the at-bats for all three of them. So this whole branch over here is now done. There's nowhere else it can go. Coming to the ball, we could have a ball, strike, or a hit. Hit, of course, we know ends it. This would be 2 and 1. Wait. Strike, ball, ball. Yeah, 2 and 1. Strike, ball, strike. This would be 1 and 2. Okay, so we'll have two branches that we're going to have to track out now. I'm going to work over here with the strike just because I think it'll be a little bit easier. So we'd have ball, strike, or hit. This would be a 2 and 2 count. That would be 1 and 3. Hit automatically ends it. Strike 3 ends it. So now we have the ball to track through. Ball, strike, or hit, which would give us 3 and 2, 2 and 3, and hit would end it. So hit ends it, strike 3 ends it. Then we'd have ball, strike, hit, which gives us the count 4 and 2. This would be the count, okay, 3 and 3, and the hit. So hit ends it, strikeout ends it, and a walk ends it. This one, all three of them end. Okay, so this path over here, where we were tracking the strike, that's done. We'll now have to come back over here. So we have ball, strike, hit. Ball would give us the 3-1 count. Strike would give us 2-2, and the hit automatically ends it. So again, we have two more branches that we're going to have to follow to the end. So let's work with this one. Ball, strike, or hit. The ball would give us a 3-2 count. Strike would be 2 and 3, and hit ends it. So hit ends it, strike 3 ends it. Ball's got to keep going. So ball, strike, hit. That would give a 4-2 count with the walk, a 3-3 count with the strikeout, and the hit would end it. So we would have all three of those would end the at-bat, taking us back over to here. A ball, strike, or a hit. Now the ball would give us a 4-1 count. The strike would give us 3-2. And so the ball ends it. The strike does not end it, but the hit will. So we've got to branch off again. Ball, strike, hit, which would yield a 4-2 count or a 3-3 count. That's a walk. That's a strikeout. There's the hit. And we've finished the entire tree diagram. As I mentioned, this thing would get horribly, horribly weird. So now let's come up and we'll go back to that orange and count how many different possibilities did we have here. So counting up the red. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 25, 26, 27, 28, 29. Man, I don't think I missed any. So 29 paths there. Does it surprise you that it matches up with the number of balls? All right, so the total number of outcomes, 29 plus 29 plus 1, gives us 59 different ways that an at-bat could go in softball. 59 possibilities. And you would have at least, I mean, think of how many different batters you have in the game as well. So incredibly, incredibly complex tree diagram. I'm going to note we built a tree diagram which would be used to build the sample space. If we wanted to, we would then have to track out all 59 possible ways, all 59 branches to create the sample space. I'm assuming people don't want to go through and do that. We were required to build a tree diagram, which could be used to build a sample space, but it did not specifically say build a sample space, so fortunately this is done. I did mention that this was a really challenging problem, right? So hooray to anyone who was able to get that one correct. It's pretty impressive that you were able to make it. Would like to further remind you, the whole point to this lesson, don't forget the learning objectives. The whole reason why we went through this is so that you would be able to determine the sample space and produce the list for the sample space. Whether you're able to mentally think through all the different options, or if you just use a tree diagram, the important thing is that you are able to find out what actually happened. If you can create the list by using a table, as we had done for the first two examples, you could use a table. If you are able to simply think through the options and map them out, that's perfectly valid. Or if you choose to use a tree diagram, all three are valid methods with the same goal in mind. Can you create the sample space? Can you figure out what can happen and how many different ways? That's all.